20.2 paper 2, a question on materials and energy. Now under this materials and energy as a topic, a subtopic is density. Okay? So this question is based on determination of what? A density. Are we moving together?
Yeah.
So it says the diagrams below show determination of density of a solid. They want us to determine the density of a what? Solid. So we have these operators. Okay, we have 1, 2, 3. Are we moving together? Yes. Then the first question is saying, what is the mass of the liquid? Okay? They want us to determine the mass of the liquid, this liquid. Okay? So what we have in the first diagram, we have an empty measuring cylinder, okay, placed on a scale. Okay? So this empty measuring cylinder, it has a mass of what? This is supposed to be what? This is 0, 5, this is 10. Okay? So the cylinder, an empty cylinder, has a mass of what? 10. Just a cylinder. Okay, without anything inside. Okay? Without any substance, any liquid inside. Okay, just an empty. It has what? It has 10 grams. Okay? 10 grams, that's the mass of the empty what? Measuring cylinder. Are we together? Then after now, putting in what? The liquid. Okay? After putting in the liquid, the mass change from what? From 10 to what? 50. Are we together? So this 50 grams, it is a combination of the mass of the empty what? Measured cylinder and the what? And the liquid. Are we together? So this 50 grams, it has the mass of the, remember the empty measured cylinder, it has a mass of what? 10. Aye. Then after we pour in what? This liquid. Okay? Then we put the same measuring cylinder on a scale. The mass changed from 10 to what? To 50. Then the question is saying, what is the mass of the liquid? So just subtract. Okay? The total mass, which is 50, minus the mass of the what? Of the cylinder. Okay? The mass of the cylinder is what? It's 10. Take note, right? Yes. Then the mass of the liquid plus the cylinder is what? 50. So for us to know the mass of the liquid, okay, which is question A. So solutions, question A. They want the mass of the liquid, okay? Mass of the liquid. Mass of the liquid is equal to, the total mass is what? 50 grams. Minus mass of the what? Cylinder. Minus mass of the cylinder, which is empty what? Cylinder. Together. So what is, we have the total mass, which is what? 50 grams. Minus what is the mass of the cylinder? It's 10. So 10 grams. So 50 grams minus 10 grams, get what? 40 grams. So 40 grams, this is the mass of the what? Liquid. You just subtract. Okay, from the total mass, okay, which is the combination of the mass of the empty cylinder and the liquid, giving us what? 50. So if you want to know the mass of the liquid, you just say the total mass, which is 50, subtract the mass of the what? The empty cylinder. What is going to remain is the mass of the what? Liquid. Are we together, guys? Okay? Yes. Let's proceed. Question B. Determine the volume of the solid. Okay? The volume of this solid. Are we moving together?
Yes.
So question B, they want the volume of the solid. Volume of the solid. So volume of the solid in this case, we just find the difference between the final volume and the initial volume. So it's like we have two levels of the liquid in this case, right? Two levels of the liquid. The first level, the liquid, it is at what? It is at 30. Okay? So this level, it is what we can call V1. Okay? The level of water at the first what point. Are we together? Before we immerse in the what? Before dropping this solid into this what? Water. Before immersing in the what? The solid. Okay? So before we immerse in the solid into the liquid, the level of the liquid was at what? 30. After immersing in the what? The solid. Okay? The liquid level rose from 30 to what? To 50. Aye. Okay? Let's say this liquid is water. So the water level, it was at 30. Are we together? It was at 30. Okay? The level of the liquid, it was at what? 30. After immersing in the what? The solid. Okay? The water level rose from 30 to what? To 50. Are we together? Okay? So now, this difference is what you call the what now? The volume of the what? The solid. The difference from 30 to 50, that is now the what? The volume of the what? The solid. Okay? This is the volume of the what? The solid. The difference from what? From 30 to what? To 50. Okay, that is the volume. So you say the volume of the solid, you can say the final volume, which is volume 2, minus the initial volume, which is volume what? Volume 1. Okay? So what is our volume 2? This is what? 50. This is our V2. 50 cubic what? Centimeters. Minus what is was our initial? What was our initial? 30. So minus 30 cubic what? Centimeters. So 50 minus 30 get what? You get 20 cubic what? Centimeters as the volume of the what? Solid. Out with. Then question C, calculate the density of the liquid. The density of the liquid. Density of the liquid. Take note. They are saying density of the liquid, not density of the solid. So we are going to say question C, D, which is density of the liquid, is equal to mass of the liquid over volume of the what? Liquid. Are we together? So you can move on and say it's equal to what is the mass of the liquid? Mass of the liquid is what? It's 40. So we have 40 grams. Then what is the volume of the liquid? The volume of the liquid, just get this. Just get this where the liquid was in. Yeah. Okay? This is the level of the what? This is the volume of the liquid. Okay? So the volume of the liquid is what? It's 8. Okay? So it's the 30 cubic what? Centimeters. Then in divide, you can say this 0 and this 0 are going to go. So what are we remaining with? We have what? 4 over what? 3. This is grams, this is what? Cubic what? Centimeters. Then you can divide 4 into 3 into 4 is what? You get 1. Then remainder what? Remainder is it 1? 1. Is it okay? Then 3 into 1 is 0, so you put a point line. Then add a 0 becomes 10. 3 into 10 is what? 3 into 10 is what? It's 3. Remember what? 1. Put add a 0 to grams 10. 3 into 10 is what? 3. So it's going to be moving on like this. Okay, so okay, just say the density is equal to 1.3 grams per cubic what? Centimeters. So this is the density of the what? Of the liquid. Are we together? Then question D, explain why the solid sank to the bottom of the liquid. They want you to explain why this solid sank to the what? To the bottom of the what? To the bottom of the liquid. Okay? So what made this solid to sink? It's because it has a density which exceeds the what? The liquid. Aye. So the solid has a density which exceeds the what? The liquid. Okay? So it just said because the solid is more denser than the what? The liquid. So we just said D, the solid is more denser than the liquid. Are we together? Maybe let's try to verify. Let's first find maybe the density of the solid, and then we compare it to the density of the liquid. Are we together? Let's try to find the density of the solid time. We see which one has a great what density time. Okay? So let's say density of the solid. So is it solid? Solid is equal to mass of the solid over volume of the solid. Are we together? So is equal to what is the mass of the solid? Mass of the solid. How to find the mass of the solid? So for us to find now the mass of the solid, in this case, the total mass in this case we realize. Okay, what we have here as the total mass. We have the total mass, it is coming from the what? The mass of the cylinder, which is A9, plus the mass of the liquid, which is what? Which is, what's the mass of the liquid? Which is 40. Are we together? So the mass of the cylinder is 10. The mass of the liquid is what? It's 40. Okay? So 40 plus 10 you get what? This is the 50. Okay? So this 50 is a combination of the mass of the cylinder and the what? Liquid. Are we together? Yes. Then what we have here, what is this mass? So this is what? We have 75, right? Then 75, we have 80, 85, and we have what? 90. Are we together? We have what? 90. Okay? So this 90 grams, okay? It's the mass of what? It's a combination of the mass of the cylinder, liquid, and the what? The solid. Are we together? That's where the 90 is coming from. Okay? Now in this case, we are supposed to now find the mass of the solid. Are we together? So finding the mass of the solid, we are going to do this. Mass of the solid is equal to 90 grams minus mass of the liquid I plus mass of the cylinder. Is it okay? Mass of the cylinder. Are we together? Then you say is equal to 90 grams minus what is the mass of the liquid? Mass of the liquid is what? It's 40 grams. Plus what is the mass of the cylinder? It's 10 grams. So 90 grams minus what is 40 plus 10? You get 50 grams. So 90 grams minus 50 grams, you get what? You get what? You get 40 grams. So this 40 grams, this is the mass of the what? The solid. Are we together? This is the mass of the solid. So we can proceed and say mass of the solid is what? Is it 40? 40 grams over what is the volume of the solid? Volume of the solid, what is the volume? It's what? 20. Are we together? Yes. Volume of the solid is what? 20. So you say over 20 cubic what? Centimeters. So this 0 and this 0 are going to go in. Yes. So 4 grams over 2 cubic what? Centimeters. So 2 into 4 get what? You get 2 grams per cubic centimeters. So guys, let us now compare these two. Which density is bigger than the other? Between the density of the solid and the density of the liquid. Density of the what? Solid. Are we together? Yes. So it's like the solid has more density than the liquid. So it's not chief inoculation. I mean, no wonder it has what? It has sand. Are we together? Yes, it has more density than the what? Than the liquid. If no wonder I was saying the solid is more denser than the what? Liquid. You've proven right? Yes. So now the last question. Is it question E? Yes. Is it question E, guys? Yes. It's saying what would happen if the irregular solid was replaced by another solid of density 0.5. Okay? So if we got another solid which has a density of 0.5, what would happen? Are we together? So let's say we get another solid. Another solid. A solid which has density what? 0.5 grams per cubic what? Centimeters. We get this one. Now let's compare. When we look at 0.5 guys, 0.5 grams per cubic centimeter and what? This one, 1.3 grams per cubic centimeters. Are we together? Which density is bigger than the other between the two? So this one is for the liquid. It's for the liquid, right? This one is for the what? Solid. So which one is bigger than the other? The one for the what? It's 1.3. So what is going to happen is the solid won't sink. Okay, it won't sink. Sorry, it won't sink, but it's going to float. Because it has a less density. It's going to sink. Are we together? The solid which is going to be replaced, which has 0.5 grams per cubic centimeter, won't sink, but it's going to what? It's going to float. So what do you say? Just say the solid will what? Will float. Fine. Because it has a less what? It is less dense than what? Than the liquid. Are we together? So this is the what? The answer. Are we together, guys? So I think